Hey everyone, welcome back to another 9-minute. So there's 3 steps to factoring a trinomial. When factoring a trinomial, there's 3 things to consider. First, always factor out a greatest common factor. Even if you can only factor out a -1, do that first. Second, you're going to do a lot of factoring, a lot of trial and error, and a lot of guess and check. Don't be scared of this. And finally, if you had any sort of GCF at all, make sure you do not answer that the problem is prime, because it's not. Now let's go ahead and deal with factoring. First and foremost, there's no GCF. 3 and 5 and -2, besides a 1, have nothing in common. And my first value, a, is not negative, so I'm not going to remove a -1. So I'm going to skip step 1 and go straight to factoring. Now, when I go straight to factoring, I'm still going to focus on the area model. I'm still going to use the same approach as before, where the first term goes in the upper left and the last term goes in the bottom right. And we're still going to focus on trying to fill in these other spaces. The difference is that the 3 gives us a problem. Instead of just putting a p and a p, I have to think of the fact that 1 times p and 3 times p would be the only combination that gives me 3p squared. Now I'm in luck because there's only one combination here. So I'm going to put 1p, or you could just put p, and 3p. And that part is still done, but you recognize that this could potentially cause an issue. Now with the 2, 1 and 2, whether it's one of them is negative, one's positive, or one of them is positive and one of them is negative, that's going to produce a -2. Here's where I'm going to switch to a pencil and I'm going to try. I'm going to just try the first pair just to see what happens. I'm going to put a -1 here. I'm going to put a +2 here, and let's see what happens. 1p times -1 is -1p, and 3p times 2 is 6p. And well, I can already see that I'm going to get lucky. Check this out. When I combine these 2 together, I get positive 5p, right? Positive 6 and -1 gives me positive 5p. So I'm done. I'm going to go ahead and write my answer of 1p plus 2 and 3p minus 1. And now I'm going to double check, right? All of these problems you should double check. I'll use pencil for this. P times 3p is 3p squared. P times -1 is -p. 2 times 3p is 6p. And 2 and -1 make -2. And it's not really important that I finish it out. It's only really important that I can confirm that it works. 3p squared matches up. These 2 are going to produce this. That matches up. And -2 matches this. That matches up. So that means that I'm correct. So now that you're factoring trinomials, let's step up our game a little to the next harder problem. So this problem presents a couple challenges. First, the values in A, B, and C are all pretty large. Also, the values in A, B, and C don't help us out because there's no common factor. Well, I guess I lied. There's a negative here, so we better make sure that we factor out a -1. So 9r squared minus 50r minus 24. So there, in fact, is a common factor. We have to take care of that -1, and now we're in the weeds, because this is the point where we better go ahead and factor. We're going to put 9r squared here. We're going to do -24 there. So nothing's really changed. The difference is that I've got a lot of combinations that I'm going to be using. And since I'm going to be using trial and error, I'm going to go to pencil. Here's the idea. I'm trying to think of numbers that can go here and here that make 9r squared. Now I know one of them is r and the other one is r, but I don't know the numbers. And I can really only think of 2 combinations, 1 and 9 or 3 and 3. And one of those is going to have to work. On the other end of the spectrum, the numbers that are going to go here and here have to make 24. And there's all sorts of options there. 1 times 24, 2 times 12, 3 times 8, even 4 times 6. All of those combinations could work. And I'm not even paying any attention to the negatives and so on. I'm just straight up just trying to find combinations that work. So the concept here is going to be, I'm going to work on doing multiplication combinations, and then I'm going to think about adding or subtracting those multiplication combinations to try to hit this number right here. I'm not even worried about the negative yet. I'm really just worried about the 50. If I can just get to 50, life is good. And I'll give you an example. If I start with 1 and 9 and 1 and 24, I could do 1 times 1 and 9 times 24. But while 1 times 1 is small, 9 times 24 is 200 and something. It's way too big when we would add 200 and something and 1 to get 50. So this combination can't possibly work. 9 times 12 is really, really big, and 2 times 1 is, well, let's see, what is that? 9 times 12 is 108, and 2 times 1 is only 2. So no matter what you do with this, you're going to get either 110 or 106. Way too big for this. I can try the other combination. 9 times 2. 9 times 2 is 18, and 1 times 12 is 12. And if I added those up or subtracted them, I'd get 30 or 6. Well, that's better, but still not 50. So let's keep moving on. 1 times 9 with the, 1 and 9 with the 3 and the 8. 9 times 8 is 72. 1 times 3 is 3. Once again, they're going to add or subtract to give me either 75 or 69, but not 50. So I'll try them the other way. 9 times 3 is 27, and 1 times 8 is 8. So I can get, well, not 50. So I'm kind of working my way down through here. 9 times 8, we're on the next piece. Oh, we did that one already. So we've done this combination, it didn't work. We did this combination, it didn't work. We did this combination, it didn't work. I have to keep trying. I'm going to try this combination. 9 times 4 is 36. 1 times 6 is 6. And, well, that's going to give me 42 or 30. That doesn't help. So I'll switch them around. 9 times 6 is 54. And 1 times 4 is 4. And, oh, sweet. All right, so I finally hit a 50. If this wouldn't have worked, I would have just crossed off the 1 and 9 because I would have tried every combination, and then I would have started retrying all the 3 and 3 combinations. It's tedious, but that's the technique. We're lucky, though, that we did get a combination. Our combination was the 9 times the 6 and the 1 times the 4. That's what gave us these numbers right here. So what that tells me is 1 and 9 work as a combination. We never needed to get to 3 and 3. So 1 and 9 go in the first part. And 4 and 6 are going to go here and here. Now, even those placements might require an eraser. So even with all of the work we've done so far, now let's do some trial and error, and let's hope for the best. 1r times 9r is 9r squared. We know that. 6 times 4 is, well, not negative. So one of these is going to have to be negative. Let's wait on that for a second. 1r times 4 is 4r. 9r times 6 is 54r. So I can see that if I subtracted these, I'd get the 50, but this is going to inform the negative. So watch this. See how the 50 has to be negative because of this sign right here? That means when I put these together, it would be helpful if this was negative and this was positive, because when I put them together, I would get negative 50. That tells me that this number, because negative 6 times 9r would give me negative 54r. And the 1r and the 9r are locked in. So this thing has to be negative and this thing has to be positive. And now I think my area model works. I can combine these together and get negative 50r. And here comes the check step. I'm still in pencil because I just never know if this is going to work. I have my negative 1. Let's not forget about that. 1r minus 6, so r minus 6, and 9r plus 4. You'll notice how I just did this with trial and error. And now I'm going to go ahead and fast forward and do some checking. And look at what we have. We have this as the check and this as the original. And what I think we now know is for sure our answer is correct.